Hello everyone, very warm welcome to all of you on the platform of KSG India. My name is Akhilesh. Today I am going to discuss about the phase of the star's life. As in the previous video we have discussed about embryo star phase as well as a red giant phase. The next phase is going to be supernova stage. How this supernova is going to be there and what happened after supernova. These are the questions which will be answered in this video. It is equally important for your optional geography as well as general studies class. So stay tuned. So in the last class we have understood that there is a red giant phase which is going to be of massive size, huge size, and this huge size is attributed to the nuclear fusion reaction that have established in the entire gaseous cloud. And after this fusion reaction, rapid fusion reaction that is going to occur in entire gaseous cloud, the expanded star is going to be called as super red giant or red giant. When the hydrogen of the gaseous cloud of red giant stage is going to be ended up, what will be the outcome? So let me explain that. As you know that there is a core of the star over here, and this core is going to have gaseous cloud that is expanded massively in big size because of thermal because of nuclear fusion reaction that has been established over here. But the fuel which was in form of hydrogen is going to be exhausted in this case also, but this hydrogen converted into helium. So helium is also having mass, and same gaseous cloud will be around this core gaseous cloud. Now this gaseous cloud is not having hydrogen, rather it is going to have helium, and the core of the star is going to be converted into other heavy elements, means helium is converting into other heavy elements like carbon, oxygen, and so on so forth. This fusion reaction is going on in this core area. Fine. So what happened when this hydrogen is going to be exhausted from the cloud? It start falling rapidly under their own gravity. So the entire cloud which was expanded start falling under their own gravity. This gravity will be there. So due to this gravity, because there is no energy which is releasing from inside, so under their own gravity this star start collapsing at a very high speed, and this collapse will lead to explosion. Massive explosion occurs over here, and lot of debris of cloud scattered in the universe. These debris of cloud containing helium scattered in the universe, and this core comes out, and this core is called as white dwarf. The core is over here, and this process which is going to occur over here is called as supernova. Supernova. So supernova explosion is what? It is the collapsing of the star when the entire hydrogen of the gaseous cloud is going to be exhausted. The gaseous cloud start falling on the core of the star, and this create a huge explosion which we call supernova. In the supernova phase, the remnant of energy which is present inside this gaseous cloud is going to be released massively. So this supernova is also known for the bright explosion. Huge amount of conserved energy which is formed due to this nuclear fusion reaction is going to be released, and this energy is actually residual energy which was present in this gaseous cloud. Fine. And this energy is released in a very large amount, and hence supernova explosion can be seen from very far. It can be the explosion can be heard. Fine. Not from the earth, but it is said that this kind of explosions can be seen from far away, by using the telescope indeed, not by our naked eyes. तो इतना तो समझते होंगे आप लोग. But this is the explosion which we call supernova. After supernova, what will happen? After supernova, the star is going to have certain kind of options, like on the basis of size the star is undergoing different stages. This size limit was given by Subramaniam Chandrasekhar as Chandrasekhar, and we call it Chandrasekhar limit. Chandrasekhar limit. What is it? Chandrasekhar limit states about when the size of a star is less than 1.44 solar mass are equal to 1.44 solar mass. Thus, after supernova, there will be formation of white dwarf. Then there is formation of black dwarf. And this white dwarf turning into black dwarf vanish in the central black hole. Central black hole of the galaxy. Fine. When it is greater than 1.44 solar mass. 1.44 solar mass. Then the star after supernova is going to form neutron star. Neutron star, which is made up of neutron only. And this neutron star is going to vanish in the central black hole of the galaxy. But when this star is massive, say for example 30 times bigger, 40 times bigger than the sun, means massive star. If a massive star undergoing supernova, it is going to change into neutron star. Yes, neutron star. But this neutron star slowly and gradually converted into black hole, a tiny black hole. And this tiny black hole ultimately vanishes in the central black hole. So try to see the difference. Difference is what? There is a stage of white dwarf, there is a stage of neutron star, and when a star is going to be massive size, it is making its own black hole. Ultimately, this black hole is going to be vanished in the central black hole of the galaxy. So this is how the star is going to lead the life. If a star is going to be smaller one, so Subramaniam Chandrasekhar is telling about that it is undergoing white dwarf stage, then it is going to be black dwarf stage and ultimately vanishes in the black hole. When the star is massive, say greater than 1.44 solar mass. Solar mass means sun's mass, na? Then it will form neutron star, which is also called as pulsating star or pulsar. Right now it is in current affair news, pulsating star, which is giving the radio waves, the pulses of radio waves. So you can find this neutron star in current affair also, and it is going to vanish in the central black hole. What happened to the massive star? It is going to convert into neutron star, then into black hole, its own black hole, and this tiny black hole of the star is going to vanish in the central black hole. This is the story. Let me explain the white dwarf, black dwarf here. So after this supernova stage, if the star is smaller, the core comes outside. And this is the core. And this core is smaller, tiny as compared to star. That's why the term has been given dwarf. Fine. So it has been given the term dwarf. And because this dwarf is containing residual heat, because once upon a time this star was the core, this core was the core of the star, so it has a residual heat. So residual heat is also radiating in form of residual heat. This residual heat is also radiating in form of radiation. That means This core is producing light. This core is producing light. Why this light is going to be produced? Yes, indeed, there is fusion reaction going on. The helium is converting into carbon and other heavy elements. But by those reaction, there is no production of energy. Energy is going to be produced only in case of hydrogen converting into helium. Fine, do remember. So, what is going on inside? The carbon converted into other heavy elements. This reaction is going on over here. That means core is going to have fusion reaction in which this helium converted into carbon and carbon into other heavy elements. Likewise, we are going to have the elements which is present in our periodic table. So, sustained fusion is the reason why behind this heavy elements are there. Fine. So, this is going on, but this fusion reaction is not going to give you energy. The energy which is produced by this white dwarf is actually the residual heat. This residual heat which was accumulated when the fusion reaction happened. तो ऐसे समझ लीजिए जैसे तवे को आप गर्म कर दें और उसे जब आप चूल्हे से हटा दें फिर भी उससे आप ताप निकलता हुआ हीट निकलता हुआ महसूस करते हैं. तो that is what residual heat. This residual heat emitted in form of radiation, visible radiation, that's why it is producing light, hence it is called as white dwarf. White dwarf. And after millions of years, which is passing through, this residual heat is going to be radiated, and this core become cooled, as well as it is the helium that has been converted into heavy elements. That means it become cool as well as solid. So when it becomes solid and cooled, certainly it is going to be called as dwarf. And which kind of dwarf? Black dwarf. This is called as black dwarf. Black dwarf. So is it visible? Answer is no, it is not visible. I have given this in black color. So here heavy elements are there. Heavy elements. All the residual heat is going to be vanished. So it is not visible. Not visible. Why it is not visible? Because it is not producing any energy, as well as the residual heat is also going to be vanished. So it is a cold body, black dwarf. Fine. So black dwarf, is it easy to see? Answer is no. What I am telling you in form of concept is going to be a statement in your prelims examination. It is equally important for your prelims. Ki white dwarf, consider the following statement regarding white dwarf. The white dwarf is the last stage of smaller star. तो सही है. Black dwarf. Black dwarf is the last stage of the stage of life of star. Black dwarf are easily visible near the black hole. It is very conclusive statement. Near the black hole you can see it, but no. Why no? Because they are not producing light. So they are not visible. Not easily visible. Is it okay? So this is black dwarf stage. So white dwarf after cooling plus sustained fusion. What do you mean by this sustained fusion? That means helium is converting into heavy elements. Heavy elements. And it was happening. It was going on in entire star. ठीक है. और इसी से पृथ्वी बनी है, टेरेस्ट्रियल प्लैनेट्स बने हैं. जब सस्टेन्ड फ्यूजन रिएक्शन वाज गोइंग ऑन, तो वी आर गोइंग टू हैव हेवी एलिमेंट्स. दैट्स व्हाई वी हैव द हार्ड सबस्ट्रेटम ओवर हियर. फाइन. So this sustained fusion was going on, cooling was going on, the black dwarf converted into white dwarf. As I told you in the previous video that this black dwarf and white dwarf is actually encircling around the black hole, and ultimately they get vanished inside. So this is the story of white dwarf and black dwarf. In the next video, I'm going to give you the idea of neutron star, why it is going to be formed, what is different, and how we can assess their presence in the space. Thank you very much.